Hey, good morning, everybody. Today we are going to look at some applications of trig. So the last 2 days we've talked about sine, cosine, and tangent, right? Sine of theta being the opposite over hypotenuse. Okay, cosine of theta being the adjacent over hypotenuse, so katoa, right? And then tangent of theta being opposite over adjacent. We also talked about their inverse. So the inverse of sine, right, is the opposite over hypotenuse, and that's equal to the angle theta. Okay, cosine's inverse is the adjacent over hypotenuse. Okay, and that's equal to the theta there. And tangent's inverse oops, did that incorrectly. Tangent's inverse is opposite over adjacent. Okay, and that's equal to theta there. Okay, so it depends on what they want. If they want a side, then you're going to use these for a side length. If they want the angle, you're going to use inverse. Okay, all right. So we're going to go ahead through some applications, like where it might become useful to use these. The first one is here in a warm-up. It says Jared is flying a kite with a string that is 200 meters long. The string makes an angle of 68 degrees with the ground. The how high above the ground is the kite, and this is very important here. It says assume that Jared is holding the string at ground level. So rather than in this picture where he's holding it here, we're going to say that he's actually holding it at ground level. Okay, and it's obviously going to be a lot longer, but we'll say he's holding it down with his foot. All right, so what you want to think about is there's going to be a triangle, right? So a string is 200 meters long, and you have, that was interesting. Let's just do this. Okay, come on, there we go. Okay, so we have this right triangle. The string is 200 meters long. All right, and he's at that, and then it's 68 degrees with the ground. Okay, how high above the ground is the kite? So it wants to know how high above is that. Okay, so we're going to use a trig function because it wants to know a side, so we're going to use regular trig. All right, so we have opposite of the 68, right? And opposite here is the hypotenuse. So we have opposite over hypotenuse, which is sine. So sine of 68 equals x over 200. Okay, so I'm going to put that over top of 1 and cross multiply, and that gives me x equals 200 times sine of 68. I'm going to open up Desmos. Come on. Ooh, it's just not my day apparently. There we go. Okay. So 200, make sure in the top right that it says degrees in the bottom. So 200 times sine of 68. Okay, so x is 185.4 feet. Okay, so a little warm up before. Hopefully you remember how to do those trig functions. All right, so now we're going to talk about angle of elevation and angle of depression. So as you can see in this image, you have this guy here, and he's looking up at the girl, and she's looking back down at him. If we imagine that we have this line that runs straight across from his eye level, and a line that runs here straight across from hers, we have two different angles that happen, that coexist, right? We have the angle of elevation, which is when if you look up at an object and there's a horizontal line, right? So that would be here. So this angle of elevation. So that's, again, if you look up. And then if we're looking down, like this girl is here at the top right, down is the angle of depression. Okay, so kind of like if you depress something down, like a can, when you're crushing a can, you're depressing it down, it's going downwards, right? So it's angle of depression. Okay, so the angle of elevation of the guy in the yellow and the angle of depression of the girl in pink are blank because of blank. So if you look and we imagine that these are straight lines, these yellow lines here, okay, we're also going to imagine that they are parallel because they run perpendicular, or parallel to the ground, right? So these are parallel lines. So that tells you that the angle of depression and the angle of elevation are congruent or equal because of alternate interior angles. So you probably remember that from GAC 1. Okay. All right, so let's go through some examples here where that might happen. Number 1, the angle of elevation from a ship to the top of a lighthouse measures 13 degrees. So if I have this ship, okay, I know it's a fantastic ship, and then you have this lighthouse at the top. Angle of elevation from the ship to the top there is 13 degrees. So angle of elevation, 13. Okay, we'll imagine this to be a right angle. And the lighthouse is 50 meters, okay, so that's the height there. So it says how far from the coast is the ship. So if this is the water, okay, we're going to assume that the lighthouse is directly on the edge, and so we want to know this distance. Okay, so we need opposite and adjacent. So this one is opposite, this one's adjacent. So that tells you that you're going to use tangent. Tangent of 13 degrees is 50 over x. Okay, we're going to put that over top of 1 and cross multiply. So we have 50 equals x times tangent of 13. And then we're going to divide by tangent of 13 to get x by itself. So x equals 50 divided by tangent of 13. 216.6 feet. Okay, there you go. A 16-foot ladder is leaning against a building. The distance between the base of the ladder and the bottom of the wall is 4 feet. What angle does the ladder make with the ground? Okay, so it's saying a 16-foot ladder up against this house. Okay, and so the ladder is 16 feet. So the ladder is 16. And the base of the ladder and the bottom of the wall is 4 feet. It wants to know what angle does the ladder make with the ground. So it wants to know what is this angle. Okay? All right, so according to this angle, this would be opposite. This would be adjacent. And this would be hypotenuse. So they give you, in this case, adjacent hypotenuse. So that's cosine. But remember, we're looking for the angle, so we're going to use inverse cosine. And then cosine is adjacent over hypotenuse. So now we can just type this into our calculator. So cosine of 4 over 16 is 75.5 degrees. So that's theta. Okay. A tree casts a 60-foot shadow with the angle of elevation of the sun measures 58 degrees. When the angle of elevation. Okay, so we have the sun up here, beaten down. Okay, and then we have this tree. Don't pay attention to my trees. And it says it casts a 60-foot shadow. So the shadow, I'll put this in a different color, is 60 feet. Okay, remember that this kind of looks like this. So there's your right angle. And then the angle of elevation is 58 degrees. Okay, how tall is the tree? So it wants to know what is this. All right, so that's going to be opposite. And this is adjacent. So this is tangent. Tangent of 58 equals opposite over adjacent. Okay, cross multiply. You get 60 times tangent of 58. Which is 96 feet. About. Okay. Let's see here. A 25-foot ramp has a vertical rise of 4 feet. So a 25-foot ramp. Okay. And a rise of 4 feet. Okay, so it wants to know, it says for safety reasons, the maximum angle of elevation of a ramp is 10 degrees. Would this ramp be considered safe? So it wants to know, do these side lengths measure up so that it has to be less than, so theta has to be less than or equal to 10 degrees. All right, so let's use our understanding. This is opposite, this is hypotenuse. So opposite and hypotenuse is sine. But now we're looking for the angle, so this would be inverse sine of opposite over hypotenuse. So theta is 9.2 degrees. So this is, yes, it is safe. It's less than 10 degrees. Okay, last one here. A cliff is 150 meters above sea level. So if I have a cliff, okay, we'll just make it flat. I don't know why I did that. Cliff that is 150 meters above the sea level. Okay, from the cliff, the angle depression of a boat in the sea measures 8 degrees. So we have another boat. Nice little sailboats here. Okay, so the angle of depression, so this angle is 8 degrees. How far is the boat from the base of the cliff? Okay, well what we know is since that angle of depression is 8 degrees, we also know that this angle is 8 degrees, so now we can just find, this value of x. Okay, well, this is opposite, right? So that's opposite, and this is adjacent. So opposite and adjacent is tangent, so this is going to be tangent of 8 degrees is opposite over adjacent. That's 150, not 10. Okay, cross multiply gives you the x times tangent of 8 equals 150. When you divide by tangent of 8, you get 150 over tangent of 8 degrees. Okay, so 150 divided by tangent of 8. So the boat is about 1,067 feet away from the cliff, about 1,000 feet. There you go. So tonight's homework, finish this exit ticket. Also, if you get a chance, you can take a look at the review to prepare for Thursday and Friday's test.